Welcome back everyone to Theory E of 5.2, the quadratic formula. Theory E is all about parameters, and what you see right here, this is B theory, so this is something that will come back at Mathematics B the most, but we have to do it, you all have to do it this year. We're going to talk about what a certain parameter is, and a parameter, you can say, is an extra variable in a function. And most of the time we use the letter p for that. Let's see how they explain it here. Exercise 25, take a look at your book if you want to, contains the function f(x) equals x squared plus 4x plus p. All values of p lead to a function of the form f(x) equals x squared plus 4x plus something. Depends what p is. Can be 0, can be 1, can be -2, can be a million. This means that you are not just handling one function, but an infinite number of different functions, depending on what p is, right? When p is 8, the function becomes this. And the graph of this function is still a cup parabola, because a equals 1, therefore a is bigger than 0, and has no x-intercepts, because in this case, if I would now calculate the discriminants, right, fill in b squared minus 4ac, gives me 4 squared minus 4 times 1 times 8. Hey, my value for p does or has an influence on what my discriminant can be. And that's what we're going to call, or what we're going to use in theory E. So in the function f(x) equals x squared plus 4x plus p, p is called a parameter. Again, ignore the hate here. This parameter, sometimes called an auxiliary variable, in Nederlands noemen we dit ook wel een hulpvariabele, actually helps you to write down an infinite number of functions in a very short way. Why infinite? Well, because p can also be anything, right? And because p can be anything, I have a lot more possible functions that I can now describe. Let's take a look at how we can work with parameters. Given f(x) equals 2x squared minus 6x plus, my parameter here p. What is the value of p when the graph of f is tangential to the x-axis? Well, here we have to use our knowledge from theory D. Tangential means that my value of the discriminant has to be 0. And actually, I have no influence on the discriminant because I can change the value for p myself. So let's take a look at the first step. Let's call A, B, and C. A is 2, B is -6. I can change those two, they are given, but the C value in this case is P, my parameter, and I can change that to whatever I want to. Using those values, I can now calculate the discriminant, right? But normally that is just one number. Here I get a function. The discriminant is equal to b squared minus 4 times a times c. A is 2, the b is -6, and the c is p. It gives me that discriminant is 36 minus 8p. And now, because I know that the graph has to be tangential, I have to say that this is equal to what value? It has to be equal to 0, because otherwise it's not tangential, right? Here they say it again, the graph of f(x) touches the x-axis when the discriminant is 0. So now solve this equation here. When is 36 minus 8p equal to 0? Yeah, you can do this, right? Linear equation. This will give me p equals 4.5. That's not the difficult part here, right? So that's how a parameter can be used to form a certain function to your own liking. What is the value of p when the graph of f passes through points p, 3p? So I'm going to fill in an x and y value for this point, in which there's also the parameter p and 3 times p. Well, let's just fill in this point, right? If they give you go through a point, so that means that this point is on the graph of the function. That means that this can be the y value and this can be the x value of that function. So let's change x into p and y equals into 3p. And let's just see what happens. Hey, all my variables now disappear. Everyone except of every variable, except of course the parameter, my auxiliary variable p. I'm left with 2p squared minus 6p plus p equals 3p. Again, the book here does the thing where here is y, right? So y changed into 3p. So you can also say 3p equals 2p squared minus 6p plus p. That's most of the time how I would write it down. But this, of course, is entirely correct. And this is a quadratic equation. Let's take a look at whether we can solve this. Of course, first try to get the right-hand side to become 0. And if you do that correctly, remember, minus 6p plus p is minus 5p, minus 3p gives me 2p squared minus 8p. And you can use the quadratic formula here, but I think that takes a lot of time. You can just use this method here, right? If I now get the 2p outside the brackets, I have a times b equals 0. I can now immediately say that the first thing here has to be 0, or the thing inside of brackets, the b, you can say has to be 0. So when does this happen? What is the value of p? Well, p equals either 0 or p equals 4. So here there are two values of p in such a way that the graph passes through the points a, p, 3p. So there's not only one solution here, there are actually two. And of course, as I said, you can use the quadratic formula here as well, just takes you a bit more time. Okay, use the one which you want. Just remember, on the test you have a limited time. So then if you can see this method, I think that can save you some time, right? And I think that's the end, right? Remember the new, quite important glossary words here: quadratic formula, discriminant, tangential, and parameter. In Dutch, by the way, parameter is a parameter, sometimes called parameter. Right, I think the actual pronunciation is parameter, and also in Dutch, parameter. Okay, good luck.